Hey nerds, welcome back. This is exercise 4I on perpendicular and parallel lines on page 268 of your textbook. Now, you might have actually heard these words before, perpendicular, parallel. Those are key points for today's lesson. And we're going to go through what they mean in real life and then what they mean in the math world of our graphs, okay? Now, they actually mean the same thing, hint, hint, but it's important that we understand what the difference is. So if two lines are parallel, and I've ripped this straight from your textbook, if two lines are parallel, then they have the same gradient. Now, in real life, there are many, many reasons why things need to be parallel, right? So for example, railroad tracks, it looks like they're going towards each other in the image, but in real life, we know that the railroad tracks will never touch, okay? So those railroad tracks are parallel because they will never touch. They're at the same angle no matter where you look at it from, okay? Now, in this image, it's because of our depth of perception, but we know that the tracks will never touch, and that's the most important part. The tracks will never touch, okay? So that's what parallel means. But with perpendicular, it means that they they come together at right angles, okay? So that means that they cross and make a perfect cross. And you'll see this in real life with these kinds of signs, where if I've drawn the lines there we go, you can see that there are right angles at every single side. And in video games as well, you would have noticed right angles there as well. So it's just in real life, we use perpendicular lines a lot, and it's also important that we compare that to parallel lines. Now, we're going to go through this really weird looking formula in a second and how to kind of cheat looking at that formula, but I want you to remember that with our linear equations, y equals to mx plus c, and remember that m is our gradient, so that's this one over here, that's our gradient, and c is our y-intercept. It's important that we actually go through that and remember that. Okay, so back to this formula over here. Now, when we're looking at parallel lines, that's this one over here, with parallel lines, we know that two lines need to have the same gradient. In other words, let's say that this bottom track here, let's say that has an equation of y equals to 2x plus 3, okay? If I'm trying to find the gradient of this line, I know it's y equals to mx plus something, right? So I know that m is our gradient. If they have the same gradient, that means that this equation is also y equals to 2x plus, and we don't know, so let's write c. Right, so it's got the same gradient. M is the same. Now, if they're perpendicular, that means that we have to go through a process. Now, you could follow this over here. Basically, what it's saying is that those two gradients need to multiply to give -1. But a way to kind of go about that is, let's say that the gradient of, let's do one of these. There we go. Let's say that the gradient of this line right there, that's y equals to 3x. Let's say it's that. And we need to find the gradient of the second line. What we need to do is we need to identify, well, what's my gradient? Well, we know that it's this one right there, because that's m, okay? So our gradient is equal to 3. So to find the gradient of this line here, which is perpendicular, all I do is, 1, flip the number, and I'll explain what that means in a second, and then 2, add a negative. Add a negative, okay? So with 3, hopefully you know that 3 is the same as 3 over 1, okay? So when I flip the number, it's going to give 1 over 3. I add a negative, and bam, that's it. The gradient of this line here is -1/3. Okay? Let's say I have a gradient that's 1 over 6. -1 over 6, let's say. To find the perpendicular, and we use these lines here to show perpendicular. If it's perpendicular, I flip the number, so instead of 1 over 6, I write 6 over 1. And then I add a negative. So I already had a negative at the front. I'm going to add a negative. Hopefully you know that 2 negatives gives a positive, so I can write +6. Okay, so that's how we find the gradient of our perpendicular line. Let's put this into practice. Let's first find the equation of a parallel line. So over here, I've got y equals to 3x minus 1. I know that because it's parallel, and it says so in the question, that means that m is equal to 3 of our new equation. Now remember, y equals mx plus c, right? So I'm going to write y equals mx plus c. I know that m is 3, we just said it. So I'm going to write y equals to 3x plus c. Now, we don't know what c is. We need to get y equals to 3x plus a certain number, okay? So what I'm going to do is I'm going to substitute the point that's given to us. I know that it's always x and then y. So when x equals to 0, y equals to 4, and I've taken this straight from there. So using this understanding, I'm going to put these numbers into this equation here, okay? And I get y is 4 equals to 3 times x, which is 0, plus c. And I know that because 3 times 0 is 0, I know that 4 equals to c. In other words, 4c. c is 4. There we go. I'm going to put that back into this equation there, not that one there, sorry, into this one here. And I get y equals to 3x plus, now instead of writing c, we know that it's 4, right? So I'm going to write plus 4. Okay, so that's how we do parallel lines. Let's do a quick one with perpendicular lines, okay? So let's go over here. I find the equation of a line which is perpendicular to the line y equals to 2x minus 3 and passes through 0, negative 1. So let's focus on what we know. We know it's perpendicular, and we know the equation of our old line. So y equals to 2x minus 3 is our old line. We're trying to find the perpendicular, so we know that m, because remember, y equals to mx plus c, right? So the gradient of our old line is going to be 2. And if it's 2, remember, to find the gradient of our new line, what we can do is let's write gradient. We flip the number, so instead of 2, I write 1 over 2. And then I add a negative in the front. Perfect. So we end up with negative half. And that's the gradient of our perpendicular line. I know m, so I'm going to write y equals 2. And instead of writing m, I write half x plus c. From there, we do the same thing we did before. So I've got the coordinate, and I'm going to highlight that there so we know. And remember, it's always x and then y. So x equals 0. So when x equals 0, y equals to negative 1. I'm going to put these numbers into this equation there. And it'll give me y is negative 1 equals to negative half. Instead of times x, I write times 0 plus z, not z, c. From there, I can solve it, and I get negative 1 equals to c. I'm going to put that back into this other equation again. I take it out, and I write y equals to negative half x, and then instead of writing c, I write minus 1. And that's how we do it. If you have any questions, let me know. It's a little bit complex, but with practice, you'll get it. Best of luck.